So we can today's class we can going to discuss the multimedia networking applications and properties of video, properties of audio, and PCM pulse coded modulation encoders and the pulse coded modulation decoders. As you know that multimedia contents are audio and the video package. Audio and video packets are a very urgent package. It is not tolerable the delay over the internet. So here analog audio signals before sending so over the communication networks. So it should be sampled at the constant rate. So some audio that is signal has to be sampled. So in the telephonic lines, suppose if the audio, so over the telecommunication lines, if the telephones, so audio can able to clearly so hear. So audio signals has to be samples. So at 8,000 samples per second. Even CD music, compact disc music, sampled 44,100 samples per second. It should be sampled. So again, each sampling quantized, that is to be rounded. So quantized, it is should be rounded. So here, example, so 2 to the power of 8, 2 to the power of 8 means it is a 2 to the power of 56 possible quantized value you can observe here. So here, how exactly sampling has been done. So for each and every audio signals, so audio signal is analog signals. So that has to be sampled. In x-axis, they have taken as a time, and y-axis, they have taken as a audio signal amplitudes. Audio signals, so the peak has to be considered, and the peak, so that is, so itself is the, so sampling has been done at the quantized values they have taken. And finally, in the sometimes quantization errors is so as also occurs. So this is exactly quantized. So analog value of analog so that is analog value. So here analog signals, it is normally they are written in a, so it is exactly, it is a sample like, so it is a curve like, it is a, so the peak of this value they are taken into consideration for the quantization, that is rounded value. Each quantized value represented by bits. Example, so 8 bit for 2 to the power of so 8 bits for 2 to the power of 56 quantized value. So we can get back. So even multimedia samples at the audio in 8,000 samples per second. So 2 to the power of 6 quantized values they have taken into consideration. So at the rate of 64,000 bps, that is the exactly 64 bps bits per second, the rate at exactly its content. Even receiver converts the bit back to the analog signals. Some quality reductions has been taken place. So here, so audio signals has been sampled at the 8,000 samples. So that is exactly the telephonic audio signals has been quantized. 2 to the power of 56 quantized values they have taken. So sampled at the rate of 64,000 bits per second, and receive the converted bits back to the analog signals. So even so at that time, so at the time of the receiver, so converts into analog signals, so back to analog signals. Some quality reductions will also be taken place. So example, so what is the rate with which exactly converts for the compact disc 1.4 and 11 so megabits per second, that is the rate. And MP3, so audio, so music format, so that is MP3 format. So here it is a 96 128 and 160 so kilobits per second, so kbps rate. And internet telephony 5.3 kbps and up to, so above that exactly it is a, so it is normally in the voice over IP application, internet telephone, it is a very useful application. So regarding multimedia, so another the thing is video. So video is nothing but what is the, how do you define the video? It is a sequence of images displayed at constant rate. So video is the sequence of images that is displayed at the constant rate. So example, 24 images per second. So has to be, so that is a sequence of images will be get back. So even digital image so contains the array of pixels. So what is exactly a pixel? So it is a horizontal and vertical lines as you observed in that. So TV screen, even so that is exactly laptop screens. So any screen, so it is an array of pixels. Each pixels so represented by bits. So that is a horizontal and vertical lines. So wherever it is exactly combined, so that is exactly that bits like it is each pixels it is a bits like it is available. A coding use redundancy within the and between the images. So redundancy within the images, that is exactly how much of so the redundant duplicate so images are observed within the images, and so between the images exactly calculating, and decrease the number of bits used to encode the images. So there are two types of redundancy. So we can observe so spatial redundancy. So that has to be two types of redundancy can be evaluated within the image, and it is a temporal. So image is nothing but so we are comparing the one image with the other images from one images with other images they are comparing. So that is what we call as temporal image. So here you see that one example they are provided. So the spatial coding. So instead of sending the n values of same color. So for example, that is a purple color is a background. Send only two two colors. So value. So two color value. So that is because it is within the image only they are compared with the color of the background color of the sky. It is purple, and the number of repeated values they have taken into considerations here. That is spatial coding. So here, so that is temporal coding is nothing but instead of sending a complete frame. So entire. So this is one frame. This is another frame. So the sequence of images together we form as videos. So instead of sending a complete frame at so I plus one, and nothing but it is a next frame, and send only the different from the frame I. Frame I is nothing but first frame and I plus one second frame. So there, what is the differences were observed? That is what we call as temporal redundancy. Differences were observed. So they are taken the differences so for one images and next images. So that is what we call as temporal redundancy. So here, so the multimedia's constant videos, so they are taken as a constant bit rate and variable bit rate. So when we are encoding the videos, so videos are encoded at the rate is fixed rate. It is a constant bit rate. So normally in the center side, so encoding rate should be considered. Even receiver side, that is so encoding rate. So whatever the rate exactly you are encoded, the same rate you are expected, the quality of images may not be changed. So here the constant bit rate is nothing but video encoding rate is fixed. So for each and every different types of video, so their encoding rate is also a differs. Examples are given in below figures. Variables are nothing but variable bit rate is nothing but so video encoding rate changes so as an amount of spatial and temporal coding changes. So here, as you know that, so as a spatial within the images, so one frame, it is exactly, it is compared within the images. What is the repeated frame? So that is exactly, it is a comparing. So only two values they are comparing, and so within the image, and it is a temporal images, one frame and other frame. What is the different so differences between the one frame? So that is the other frame. It is a comparing. That is what we call a strict temporal. So as you the what is the amount of spatial and temporal coding changes? So that is a variable bit rate. It is a exact. It is a appears. So examples for the motion pictures expert group version 1. So that is a CD-ROM. Normally in the compact disc ROM. So normally 1.5 Mbps. That is the rate of running of this CD-ROM. MPEG 2. So it is a DVD, digital videos decoders. That is exactly DVD version 3 to 6 Mbps. So MPEG version 4. So often used in the internet. Normally MPEG version 4 nowadays is very popular. Should be used in the internet for. It is a 1 Mbps the encoding rate. So these are all the so various encoding rates. It is exactly given as an examples here. So in this class, so we have discussed about what is the multimedia networking application. So multimedia is a so very important. So it is a audio and videos can be able to send over the so internet. So audio and video is an urgent packet. So delay is not tolerable. So these kind of how exactly, so what are the properties of audios and properties of videos that has been learned, and what is the sampling rate. So in the properties of videos concerned, so what is exactly the, so that is a constant bit rate and variable bit rate. So always users are expecting the constant bit rate of delivery of data, but due to so delay in the networks, so variable bit rate also available. So whatever the encoding rate, so it is expected, so without any so delay, so without any quality of services. Okay, so quality of services is guarantees, so without any delay in receiving of the signals, initial buffering, so normally it is taken place. It is without flickering of images, so without, so that we can able to play out the video, it is possible. So I think in the next discussion I'm going to discuss. So pulse coded so encoders and pulse coded decoders we are observed in the quantized values. I think it is a pulse coded encoders and quantized values how exactly rounded up we have learned. So I think that's all about this class.